to discuss the Job's method. By using this method, we're going to determine the composition of the metal complex. If we consider the metal complex MLN, N will be the composition of the metal complex and can be given by the ratio of concentration of the ligand and concentration of the metal ion. And this method can be used to only one complex is formed under the experimental condition. So if we see the procedure involves in 3 steps. In first step, we are making 10 solutions with the same value. Okay. So number of solutions, how many solutions we are preparing here? 10 solution, 1 to 10 solutions. So volume of the metal ion is going to increase like 0 ml, 1 ml, 2 ml to n ml. And volume of the ligand will be added as 10987. So total volume is considering as 10 ml, right? So the total concentration of the ligand and the total concentration of the metal ion is considering as the constant C. In next step, what we are doing is measuring the optical density. That means they are measuring the absorbance for above 10 solutions by using the spectrophotometer. In third step, we drawing the graph between absorbance versus mole fraction of the ligand. What is mole fraction? Mole fraction of the ligand is total concentration of the ligand by constant. So if we see the graph, absorbance versus mole fraction, the absorption peak will come like this. If we extend the graph, we will get the maximum absorption point like this. So what is our main theme? Determination of composition, right? So composition of the metal complex. If the metal complex is MLN, the composition N will be ratio of total concentration of the ligand and total concentration of the metal ion, right? So if we consider this equation as 3, equation 1 can be written as, so what is equation 1? Equation 1 is total concentration of the ligand, total concentration of the metal is constant, right? So we are rewriting the equation as by dividing all the terms by constant C, right? So Cl by C, Cm by C and C by C equals to 1. So as we know from equation 2, the mole fraction equals to total concentration of the ligand by constant, right? So we substituting here Cl by C place, we substituting the mole fraction mf, right? And Cm by C equals to 1. So from this we will write Cm by C equals to 1 minus mole fraction. So if we take this equation as 4, the equation 2 will be divided by equation 4, right? So Cl by C into C by Cm and mole fraction by 1 minus mole fraction, right? So this equation will come by Cl by Cm equals to mole fraction by 1 minus mole fraction. So the composition will be considered as ratio of concentration of the ligand, concentration of the metal ion, right? So N equals to mole fraction by 1 minus mole fraction. So the composition of the metal complex will be determined by using this equation.